Hey everyone, here we go, big day. All the curves on the polar graphs. At the top are all the patterns. I'm going to go through all the patterns. You can certainly read all that, but I'll show you what these patterns mean. But it's all written here in words if that helps you to sort of decipher what's happening. So I'm just going to start graphing. I know you can read that. So if you put this into your calculator, you will see what it looks like. Obviously, I sketched it for you already. But when you have multiplication in front of your angle, like 4, 5, 6, things like that, not a 1, but a number that's not a 1, then this is going to create a rows, and we're not adding or subtracting. So rows is like all multiplying. If your petals are even, then you take 2 times n. That's how we knew it was going to be 8 petals. So this is 8 petals. If you have an odd number, then that's just n. Now the length of the petal is the number out in front. So each petal has a length of 2. Knowing this can be very helpful. So the petals will be split up equally around 360 degrees, and it's very important that you place those petals on the correct angle measure and that you do the correct length and the correct width on each petal. Very, very picky. So if you were graphing this, you would need to know what angle this was on and then how to get the exact width above and below that point. So you would have to graph 3 points for each petal every time we have a rose. So again, multiplying, no adding, we know this is a rose. Oops, if I can write. Odd number, so that means we have the n length of n number of petals is n. So we have 5 petals, but again, that number out in front is the length of each petal. So those are tedious to graph and kind of hard to graph. So be on the lookout for those. If you are adding or subtracting, then you're going to get a shape that either looks like a heart or a heart with a loop in it or a circle with a flat side. And I'll show you what this looks like. So if they match, they being the number out in front and the number that you're multiplying the sine or the cosine by, this is going to be a cardioid. We're not going to call it a heart. We're going to call it a cardioid. And because this one has sine in it, it has symmetry like a circle does. Sine means symmetry with the y-axis, which should help you draw the graph. Work smart. You don't have to graph both sides. If you know the symmetry is there, you can just say, okay, I know that it's this far on the right, so it's going to be the same on the left. So 2 plus 2, if you add those two numbers together, obviously this equals 4. This equals your far length, or your the one that's farthest away from 0, 0. And you know it's going to be on the y-axis because of the sine. The first number, it's hard to know what I'm talking about. The very first number, the one out in front, the 2 that's not being multiplied, this is your left or right number. So that's how many spots you're going to go left or right. Left and right, I should say. So if you look at the graph, this will help you in terms of knowing what's happening, but we can take some shortcuts. So we know that the number farthest away is up the y-axis because it's sine, and it's going to be up 4. And then so that means left and right is going to be 2. And that might be all you need in order to graph this thing. So a cardioid is a circle that looks like someone sort of dented in one thing. So it really is supposed to be a circle. It is not a heart. It does not come to a point down there. It really is a circle with a little dent in it. Cardioid, numbers match. If the numbers do not match, you're going to get a limaçon. Limaçon. And I wrote it up there phonetically for you, so it has a little thing on the C. I don't know, I don't do French, but so if you have a smaller first number, then you're going to have a loop. So this is a limaçon with a loop. And you have to draw the correct points to make the loop the correct length and the correct width and all this good stuff. So this one is cosine, so it is symmetry with the x-axis. which again, use that to your advantage so you can graph smart. If you add the two numbers, this is the length or how far out the outer loop will be. If you subtract the two numbers, then this is your length or how far away from the origin of the pole the inner loop is. And the first number, this is your up or down in this case. So the other way, other direction of the length, the long one. So if you had like a one above, if you had sine, then it would be left and right. So, and you can kind of tell with how my graph is that we know we're going to do this. So we have 0, 0. And 1 plus 2 is 3. So 3 is the outer loop. 1 minus 2 is 1. So 1 is the inner loop. Up and down is the first number, so there's your 1 up and down. Now, that should be enough. Look at the graph, put it in the calculator, look at it. This should be enough to sort of help you come up with this sketch. Now, it's kind of interesting if you watch the calculator draw it. Right? It draws it, and then it draws the outside one. So it looks like a cardioid. I'm not so good at drawing this very circular. It looks like a cardioid, but it has a little loop in it. And we call that, again, we call that a limacon. Now, imagine when we don't have really any numbers to subtract, right? So the numbers out front are bigger, so we can't really subtract, because this would be like 0 minus 2. So if we subtract, we get a negative number. So if the first number is bigger than the second number, this is a limacon with no loop. And of course, this one is cosine, so it has symmetry with the x-axis. You're going to be asked about this symmetry. It happens a lot. Add up the two numbers, so the coefficient out front is a 2, and the coefficient of the cosine, the coefficient in front of the cosine. And so this is your how long your far space is. We don't have an outer loop. Up and down is still your first number, and so that's a 2. So we know that we're going to be 3. Up and down, we're going to be 2. Now what happens with this is if you look at it, you might even have to zoom in. You might even have to plot some points. Right around the 1 is flat. And so look at this, it's like right around, I don't even know, like 120. And you can kind of tell if we were to superimpose what that point would be, that's kind of where it stops. And then it turns into a circle. So when you have no loop, it's flat. So I don't know if reading the explanation helps you, but I explained it again. All right, so the length of the petal, the symmetry, all the good things. So look at the first problem. It says name the polar curve and describe the symmetry. So you're going to have to kind of know this. You can always put it in your calculator and take a look at it, but kind of knowing this helps. So here we have the second number is larger. And when the second number is larger, we get a loop. So this is a limacon with a loop. You cannot just say limacon. You got to be specific. So if you're not sure, look it up, or graph it rather, with a loop. And of course, the sign means it has symmetry with the y-axis. -3 cosine theta. Well, it's all multiplying, but there's no number that's larger than 1 in front of theta, so this is a circle. And this has symmetry with the x-axis because of the cosine. Now, we're concerned with this right here. That one is multiplying, and now we have a number in front of it. It's odd, so we know we have 3 petals. It doesn't ask for that, but just to kind of go through it. So this is a rose, and it has symmetry with the x-axis because it says cosine. Now, what's interesting about these is you can write a lot of equations for the same graph. So we have a rose with a symmetry with both axes. Has 4 petals, each with a length of 5. So we know this is going to be r equals 5. We can do cosine 2 theta. Has 4 petals. Remember, if it's even, we're going to have to multiply by the 2. Or you could go -5 cosine 2 theta. When it's symmetry with both axes, that's kind of controlled, honestly, by the number of petals. then, or we could do sine, right? Because it doesn't matter. So we have r equals 5 sine of 2 theta, or you can make this negative 5 sine of 2 theta. You don't need all of these. You just pick one of these. Graph them. They're all pretty much the same graph. They all have symmetry with both axes. Petals might shift a little bit, but it didn't say specifically like what it's supposed to be, so has lots of choices. So we have inner loop, which means A is smaller than B. And we need to use cosine because it's x-axis. So pick two numbers. I don't know what two numbers you want to pick. 3 plus 4 cosine theta. You want to pick r equals 1 plus 2 cosine theta. You pick. The first number has to be smaller than the second number. How much smaller? Smaller. Doesn't matter. Obviously, if the numbers are closer together, it's a tiny bit easier to graph. So you're not asked to graph it, so you don't care. Now we're going to graph this. State the interval for theta where the graph is traced only once. You can kind of tell by watching this, or if you need to graph a whole bunch of points, you can tell by doing that. So we know we have a cardioid because the numbers match. We also know that our main length is going to be 4. It's cosine, so it's also a negative in the middle, so we're going to go to the left. So we're going to count by ones. This is tedious to graph, honestly. The first number tells you how far up and down we'll be because it's the other direction. We know we're at 0, 0. Now, to get this on the graph pretty good, look at the table. Look around 45 degrees, right? Because that seems like what we need to know. And graph that point. Looks like it's a little bit bigger than 1. Can't really graph that too well. Oops, that's 2. There's a little bit bigger than 1, which means the symmetry is there. So if we go down 45 degrees, it's going to be right around there as well. And again, that's a little bit hard to get on there. So I have a wrong point. And then we graph this. So if you watch it carefully when the calculator does it, you can almost tell that it needed all 360 degrees.